Hi, I'm Victoria and I'll be going over prompt number 1. Here is our given DNA sequence. The top strand will be our template strand and transcription will take place from right to left. And here is our resulting mRNA product from transcription. When the mRNA is translated, we get the 5 amino acid sequence shown below. We're now going to look at a point mutation in the DNA that changes a cytosine to a guanine in the coding strand. This is a transversion since we're going from pyrimidine to a purine. And at the bottom is the resulting mRNA sequence. When the mRNA sequence is translated, we get the exact same amino acid sequence as the original wild-type DNA. This is a silent mutation since there is no change in the amino acid sequence. A silent point mutation is sort of like a substitution in a recipe, since GGAUGC and GGAUGG both code for valine, and buttermilk is the equivalent to milk and lemon juice in a recipe. We will now change the thymine in the wild-type coding strand to cytosine. This is a transition since T and C are both pyrimidines. Now looking at the amino acid sequence, from the mutated mRNA, we can see that phenylalanine from the original sequence has changed to serine. This is a missense mutation because it changes one of the amino acids in the sequence. For a missense, I think about swapping food at lunch. If someone has a cookie and you want chips and you trade, it's kind of like how one amino acid is swapped for another in a missense mutation. Here's a different point mutation where adenine is switched to thymine in the coding strand. This is a transversion, and at the bottom is our new mRNA sequence. As you can see, the resulting amino acid sequence is shorter compared to our original amino acid sequence. This is because the UAG codon now serves as a stop codon. A nonsense mutation is kind of like falling asleep while you're doing your homework, since you stop too early and don't finish. Our next point mutation is where thymine is changed to guanine in our coding strand. This is a transversion, and at the bottom is our new mRNA sequence. Now when our mRNA sequence is translated, you can see our amino acid chain is much longer compared to the wild type. This is because our original UAA stop codon was changed to GGAA, which now codes for glutamate. And the tRNA keeps translating since there is no stop codon. This is known as a read-through mutation. A read-through mutation is kind of like running a red light, since you keep going even when you aren't supposed to.